Hello everyone. Today I'm going to be talking about help dice math. Now, I've talked about help dice a little bit in a previous video talking about average values, and I pointed out the average value of a help die, but today we're going to be going a little bit more in depth in help dice because it's actually a much more difficult and nuanced math topic than people might initially realize. So first off, let's talk about what help dice are. Help dice are something you add to a roll, typically a check, that's going to be a d4, a d6, or a d8. Now, by default, a help die is a d8, but if you use help die multiple times, it's going to go down in value from a d8 to a d6, and then from a d6 to a d4. Now, talking about those average values, we can see that if I roll a d8, that's going to be about a 4.5, right? So if I'm adding the d8 to the roll, I should expect that on average it's going to come out to being plus 4.5 to that roll. A d6 is an average of 3.5, and a d4 is an average of 2.5. So let's keep this in mind and talk about and refresh ourselves on the chance to hit, right? Obviously, this chance to hit is something we can apply also to trying to roll against a DC, right? And if I use my chance to hit, it's going to be 21 plus my attack check or whatever the bonus is to the roll, minus the defense or whatever the DC is over 20. Let's think about changing this equation for help dice. You might expect it to look something like this, where we have an attack check against a defense with an average help die bonus of H, right? So in this case, that would be the plus 4.5 for a D8. So we just add the H as part of our bonus. It almost kind of becomes part of the attack check. But this isn't totally quite right. Now, it's an easy simplification, and if you want a ballpark number, it works fine, but let's talk about why this doesn't totally work using a little bit of an example. So, what's our chance to hit with help, right? Let's take the scenario. I want the chance to hit an enemy with a PD of 30, and yes, this is a very large PD, when you have an attack check of +4 and a D8 help die, right? So, obviously this PD is very high. We can think about it maybe as a brutal chance if you want, although that changes some of the logic. But for now, let's think about it using that average value. So our D8 is a 4.5, so the total bonus to hit should be about an 8.5. So we can either round that to an 8 or a 9. So it should be impossible to hit without a crit, right? Because there's no way I can roll a 30 on the dice if I'm adding an 8.5, either an 8 or a 9. Even if I have a +9 to the roll, right? If I roll a 20, that's still a 29. So I'm never going to hit that 30 mark. Obviously, if I land a crit, that's going to count as a success. But the reality here is a little bit more complicated, because if we roll an 8 on the D8, it could give us a total of a +12 as a bonus to the roll. And so that would let us hit on an 18, 19, or 20, right? So if we roll an 8 on the D8, we have a 15% chance to hit. And adding on to that logic, if I rolled a 7, that would give us a +11 bonus to the roll. And so that would let us hit on a 19 or a 20. And if we rolled a 6 or lower on the D8, basically anything else, then we would need a crit to hit. So in reality, when we roll a help die, there's this chance, right, that we roll an 8, and in that situation, then I have a 15% chance of hitting. If I roll a 7 or on the D8, then I have a 10% chance of hitting. And if I roll anything else on the D8, then I have that regular crit chance of hitting. So this is why things are a little bit more complicated with help die. Help die have this range of bonuses that they can apply, and some of those bonuses might be enough to reach that next level of heavy hits or brutal hits or even just a regular hit. And so we need to kind of factor in these different possible outcomes of rolling the D8. Adding an average isn't going to represent that, right? Adding the +4.5 would tell us that we're always going to just need a crit to hit, but that's not quite true. If I roll an 8 or a 7, I can hit on a 19 or an 18 as well. So let's break this down a little bit further. So we're taking this scenario where I have the chance to hit an enemy with a PD of 30 when I have an attack check of +4 and the D8 help die. So the chance to roll a specific number on D8 is 1 over 8, right? So that's whenever you're trying to roll a dice and there's no advantage or anything weird, then the chance to roll any specific number on that is 1 over the amount of sides on the dice. So for a D8, it's 1 over 8. For a D6, it's 1 over 6. For a D4, it's 1 over 4, right? So in the case of a D8, 1/8 is also in decimal form 0.125. So what we do is we take our chance to hit and we kind of split it up in pieces. So the first piece is 0.125, right? That 1/8 times 0.15. That's my 15% chance of hitting, right? That's basically telling me right? That I have this chance to roll an 8 for help and the chance to hit when I'm rolling an 8 for help, right? The next one is showing me this chance to roll a 7, right? Which is 0.125 still, right? There's the same chance of rolling a 7 as there is a chance of rolling an 8. But if I roll a 7, I only get a 0.10, right? Basically a 10% chance of rolling and hitting. And if I roll a 6 or lower, that's 0.75, that's every other number on the D8. Well, then I have this 0.05, right? This 5% chance to crit and hit. So overall, if we kind of, multiply these out and add them together, I'm going to end up with 0.06875, right? Or really a 6.875% chance. So we can see that if I roll with this D8, it actually makes it a little bit more likely than a crit for me to be able to hit. And that's because of those situations where rolling an 8 or a 7 actually expands the amount of numbers I can roll to hit. So how can we write this as an equation? Well, it ends up being quite long because we need to kind of take each of the individual numbers on the D8 and kind of add them up separately, right? So if I have my top row kind of shows the way I did it before, right? In this case, it's 1/8 times the chance to hit if I'm adding an 8 as the bonus, right? So we can see that I kind of have that 21 plus the attack plus help minus defense, but I'm going to have to add each value of the help individually. So it's 1/8 times the chance to hit if I'm adding 8 to the roll, plus 1/8 times the chance to hit if I'm adding 7 to the roll. And I keep doing this over and over again. I do 1/8 times the chance to hit if I get a 6 on the roll, plus 1/8 times the chance to hit if I get a 5 on the roll. And we do that and we add those all up until I get the final one, which is 1/8 times the chance to hit if I'm adding just a 1 on the roll, right? And so what we can do is we can kind of pull out that 1/8 to the front, right? Because all of these are going to be multiplied by 1/8. It's just 1/8 times the chance to hit if I'm getting an 8 on the roll, plus the chance to hit if I'm getting a 7 on the help die, plus our chance to hit if I'm getting a 6 on the help die. And we just go through and we add those up for all of the help die options, right? For every possible roll we can get on the help die. And so this really ends up being our result for the hit chance, right? If we're getting our hit chance, then with a help die, we're going to basically have to find every single scenario, right, of every possible roll of the help die, because each one results in a slightly different probability, right? So let's expand this a little bit using the D6 and the D4. And really, there's not that much of a change here, right? The same logic applies, but the difference is that we're using different dice. So we can see here in green, I've kind of pointed out the differences. Well, instead of being 1/8, for the D6, we're talking about 1/6 because there's only a 1 in 6 chance of rolling any side on the D6. And then on top of that, I'm going to add the +6, +5, +4, right? Instead of counting down from 8, I'm counting down from 6. And then for the D4, same kind of change, right? It's 1/4 because there's 4 sides on the D4. And then instead of adding, +8, +7, yada, yada, I'm going to add +4, +3, +2, +1, right? And that covers all the rolls on the D4. So adding a D4 in help is the easiest because there's just the least amount of numbers that I'm adding with the help. There's the least amount of possible rolls I get on the D4. But in reality, the math isn't too much more complicated for each one. It just involves more, putting numbers into a calculator. But if you have this automated on something like a spreadsheet, neither of these are really harder or easier than the others. There's just a good amount of kind of coding it all in. Okay, so let's talk about a tricky situation, multiple help die. Now this makes things a little bit more complicated than just a regular D8. So if we have a 2D8 help die, how is this different than our regular 1D8? Well, obviously we have a larger possible bonus, right? But the probability of each result is different. When I'm rolling a 2D8, I don't have an equal chance of rolling everything, right? 2D8 can give me a minimum of 2 and a maximum of 16, but those aren't all equally likely. And so we can see here on the left, I have used this website, AnyDice. If you want to look up dice probability, I think it's a really easy way to do it, especially for someone who's familiar with TTRPGs, because it just inputs values like 2d8, and then it'll let you know what the probability is of rolling any result on the 2d8. So this is going to show us the percent chance, right? So we can see here the most likely outcome is rolling a 9. There's a 12.5% chance that I roll a 9. And the least likely outcomes are a 2 and a 6, which involve a 1.56 and a 1.56% chance for both. If you want to think a little bit about the logic of why it's more likely to get a 9 than a 16, think about it this way. There's only one possible way for me to get a 2. I need both of the d8s to roll a 1. And there's only one way for me to get a 16. I need both of the dice to roll an 8. But there are many ways that we can get a 9 with a d8, right? I could get a 1 and an 8. I could get a 2 and a 7. I could get a 3 and a 6, right? We can keep adding up all these different combinations. So there's more ways to get a 9 than there are to get a 2 or a 16. And that's why 9 is more likely. And this logic kind of, you can see, stretches out over the range of numbers. The further we get from the center, the less likely we are to get that result. So we get this probability of each result being different. We get a larger range of values, which means there's more math to do, right? There's more of these different probabilities I have to calculate for. And it allows for much greater levels of brutal hits, right? Which means that we kind of need to account for a lot of a higher possibility of brutals, right? Normally the equation I show off really only has a regular hit, a heavy hit, and a brutal hit, and then critical hits. But in reality, when you're adding help die, it's very likely that you're going to have a regular hit, the option to get a heavy hit, the option to get a brutal hit, the option to get a brutal +1, the option to get a brutal +2, right? To get higher levels of brutal hits because your bonus is getting so large. So this is the key idea of adding these help die, right? You have to keep in mind that there's these complexities added to the math, but we can think about how this connects to our previous way of talking about it, because basically our hit chance when we're talking about, adding help die is the chance to roll that bonus times the chance to hit with that bonus. And we go through and we add that up for each individual possible bonus on the roll, right? So we repeat this for each bonus. For the 2d8, that's everything from 16 to a 2. So it'd be the chance to roll a 16 on the help die times the chance to hit if I got a 16, right? And so in that equation where I have the chance to hit and I'm adding the bonus is a 16, right? And then I add the chance to hit when I'm rolling a 15, and then, the chance to roll a 15 on the help die, and then the chance to hit with a 15. And I go through and I add up all of these chances. So obviously this would look really long if I try to lay it out here. It's a really, there's a lot of probabilities I have to add up, but it's not particularly complicated. It's just a lot of math. The most complicated part is just finding out, this idea from before, which is the probability of getting each of the results, right? But for that, I would just recommend using a website like AnyDice that's going to give you these probabilities, right? You don't need to do all of this work just to figure that out, right? You can if you really want to get into the weeds, but if you want to get that much into the weeds, you probably already have an idea of how to figure it out, right? For the purposes of trying to do this math, it's easier to just set up a table like this and look at what those chances are and then add them all up. So this kind of covers how we do math with multiple help dice. So let's bring this to our idea of calculating damage. If I wanted to calculate damage with help die, right, I do it the same way I normally calculate damage, right? So here we can see our ways to calculate damage, laid out from the attack math video. And what we have to do is this hit chance, right? This 21 plus the attack minus the defense over 20. We want to replace that with the overall chance to hit with the help die, right? So that's the number that we're getting when we're kind of finding that total hit chance represented here, right? Where we're adding up all of these individual possible results in the help die. The final answer there is what we put into our hit chance for our regular hit or a heavy hit or a brutal hit or our higher levels of hits, right? Even the brutal +1, the brutal +2, whatever you call them, brutal, mega brutal, everyone has different names for them, right? But these different levels of brutal hits, those are all going to have a different sort of terms included in here, right? There's +1 times the chance to get a next level brutal, right? A brutal +1. Which in this case would just be 6 plus the attack minus the defense over 20, right? Each time we go to a higher level of brutal, this number in front of the attack and the defense goes down by 5. So it starts at 21, goes down to 16 for heavy, goes down to 11 for a brutal. It's going to go down to a 6 for a brutal +1, and it goes down to a 1 for a brutal +2, right? So the further we get to brutal levels, the harder it is to actually hit. But this is the things to keep in mind when we're doing math with help die. So with damage, all we're doing is we're taking our hit chance and we're adding in this kind of more complex hit chance that takes into account our help die. Critical hits are unaffected. That's the nice part about this. We don't have to really worry about anything different for critical hits. They're exactly the same because critical hits don't care about what the result is. They only care about what you're rolling on the D20. So critical hits are affected by things like advantage, but they're not affected by things like help die. So we don't have to worry about them in this video. Okay, and that's everything I really wanted to cover on help die and help dice math. I hope this video was helpful to kind of give you an idea of why help dice are a little bit more complicated and nuanced than people originally think, right? We like to say that help die are like a +4 or like a +5, but the reality is a little bit more complicated. They unlock new and higher levels of brutal hits, and they allow for this sophisticated chance of being able to hit a target only when you roll on a high number on the D8. And really, the more accurate scenario is that you have a higher chance to get a brutal hit. When you're rolling with a D8, right? You might have a low chance originally, but that chance goes up with a D8, right? You might even have a chance to get something like a beyond brutal, right? A brutal +1 on a target because you have a help die when you originally were not able to do that without the help dice. So, as always, thank you so much for watching, and until the next time, have the best time.